and Chabot, and we are doing our very first ever visit, this time to the Automotive Technology program in the Automotive Technology Lab. And I'm here with Stephen Small. Hi, Stephen.
Good afternoon, Catherine.
So what we want to do today is take you around and show you some of the actual equipment and talk about what is done here and what students learn when they're part of the Automotive Technology program. So we'll start by looking here to my left. Stephen, can you tell us about this piece of equipment?
Yes, we deal with ATEC training systems, and this is one of the ATEC lighting system trainers. We use it for helping the students understand what goes on in a vehicle's lighting system prior to actually doing physical work on the car. That way they have an idea what the layout is, they have an idea how to make some voltage and voltage drop checks. That way when they go to the car, it's a little bit more
clear?
It's a little more clear. It makes it a little bit easier for them to understand because they've already done it on a training board. Okay? They're not digging out the wiring harness in the whole car.
So what we're actually seeing here is this car, kind of the lights from this car?
Yes, this training board simulates a 1992 Chevrolet Cavalier lighting system, which is pretty much similar to what they might work on in industry.
Well, it looks simple enough for even me to understand. I see there's the marker lights, I see that there are the headlights and the tail lights all on one board. Gosh, this doesn't seem very intimidating.
It's a lot less intimidating to see it on the board like this than when you start going after it in the car, because everything in the car is, all the wires are hidden, they're buried. Okay, a lot of this stuff you don't have direct access to, connectors and things like that are in specific areas in the car, which you may have to take upholstery, seats up, dig up the carpet and stuff like that to gain access to some of those, the connectors and the grounds and so forth in the vehicle.
Excellent. Can you show us some of the other equipment here in the lab? I think we'll go over in this direction.
Okay. We're in the main auto lab in our room 1426 and building 1400. This building houses both our automotive program, the machine tool, and the welding programs. Here in the main auto lab, this is where we do most of the physical work on the vehicles. Okay, so we bring the vehicles in here and we do brakes, steering and suspension, electrical work. Some of the transmission work is done in here, engine diagnosis. Also, we do emissions testing and other electrical testing for the vehicles in here. We also do our brake machining in here, which is all part of what we do, is our main focus in this lab. Okay? So we have tire mounting machines and balancing machines, front-end alignment machines. Okay? We have 2 dynamometers that we use for emissions diagnosis, and also we use them for other things like trying to diagnose a transmission shifting problem or looking at an engine electrical problem under load, similar to driving it down the highway.
So let's take a look at some of this equipment now.
Okay, Catherine, this is one of our emissions analyzers that we do for doing smog checks. Along with one of the dynamometers here in the background, we have 2 side by side, and we use these dynamometers for training the students on how to do a smog inspection on a vehicle. We also use them for emissions diagnosis, drivability concerns and things like that. Even something as simple as doing a speedometer check, because they're very accurate for the speedometers. So speedometer, odometer checks fall into that. And we can use them for transmission shifting problems to see if the transmission shifts correctly. All that without having to take the car out on the road.
That's excellent. And what about this piece of equipment? What are we looking at here?
Well, this is the computer that interfaces with the dynamometer. This is the brains that runs the dynamometer, tells it how to load the vehicle correctly and the things that we're going to do, programs it in. For emissions testing, we program the vehicle's information into the machine. It then connects to a database within the machine, finds all the pertinent data for the vehicle, and then correctly loads it for an emissions test.
And so students, when they come here into this program, is this the same kind of equipment they'll find in the workplace?
Yes, it is. Okay, they will find this very same type of equipment out there. There's essentially 4 emissions analyzers that are in use out in the field today, and we have 2 different models. We have the worldwide machine here. We also have a Sun analyzer, which is one that's out there. that they use, and then there's a couple more that they may come across. They all operate very similar.
So when the student comes out, are they certified in the use of this equipment, or how do they demonstrate their proficiency?
Well, one of the things I do on this piece of equipment, there's a couple of things we do, but the first thing is I see if they can drive a car on the dynamometer. And what we find out is some of them can't drive a clutch very well. It becomes a real issue when they can't drive a clutch or stick shift car, because the dyno loads things, and it's not like we're driving a car in the real world. So it has a little bit of a different feel to it. So that's one of the things, is the first thing is getting them used to driving a car on the dynamometer, especially if they haven't used a clutch. Automatics are pretty simple and pretty straightforward, but there's still some nuances. They can get a little carried away, especially on the front-wheel drive cars, trying to steer it when they shouldn't and just let the car go. Just let the dyno do its thing, and it's pretty much straightforward. Okay? And then teaching them how to program the machine, put the correct information in it, and then following the instructions per like our smog check manual for doing that, and doing a correct inspection on the vehicle, inspecting all the emission control devices, running all the tests and performing all the tests correctly. So that's part of what I watch for during my emissions class. Okay, Catherine, over here we have this Cadillac that's on one of our two front end alignment racks. Okay, it's just positioned here right now, and then if we were to do an alignment on it, the students would set it up, hook all the measuring devices up to the wheels, and then the machine will automatically tell us if the alignment specifications are where they're supposed to be and if any adjustments need to be made. On the other side over here we have our newer alignment rack, which is completely computerized, light emitting diode activated, does not require any strings or anything like that to the dyno, to the alignment rack. And you can see kind of how it is set up. You drive the car up on it, you position it correctly, and then you hook up the alignment heads to the wheels, and then you can perform your front end alignment or four-wheel alignment, as the case may be.
And so the students take these as individual classes. Tell us a little bit about the program and how this all works.
Well, we have classes that, for in this lab, the classes that we primarily run, we run the steering and suspension class, we run a brakes class, we run an engine performance class. We also do transmission work out here. We're removing and replacing the transmission. Wheels and balancing is part of the steering and suspension class. Machining brake rotors, again, part of the brakes class. So we have various things we do. We also do engine diagnosis if the engine class has an engine that needs to be diagnosed. And sometimes the engine performance class also does engine diagnosis.
Well, it looks like a very busy place. If we take a look around here, I see we have a number of cars being serviced right now. So students really get some very practical, hands-on experience throughout the whole program.
Yes, they do. Currently, this is the brake and safety inspection class, and we have students working on brakes and inspecting brakes and doing some various other things that are pertinent to that class.
And I think there's another lab that you wanted to show us.
We have two other labs, and we'll go that way. One is the engines lab, and one is the transmission lab.
Great. Shall we go there? So, Stephen, where are we now?
This is our engine lab. This is where the students take engines apart, they clean them up, inspect them, and then do a machining process to renew them and make them like new again. We machine blocks and cylinder heads. They grind valves, replace seats, valve guides, machine the head surface to make sure it's straight. They also do that on the blocks to make sure everything is ready to go. Refit pistons, recondition connecting rods, and so forth. We do everything but regrind a crankshaft or a camshaft in this class. Well, we may not get back to the fully running part, because the fully running part is getting the engine back in the car. And a lot of times what the students do, they bring their engines in, they remachine them, assemble them, and put them all together, and then they're going to put the engine in on their own at home or someplace else, and then they'll get the engine running. Right over here, we have quick-way valve grinders. These grind the valves, okay, to the correct angles and make the valves concentric again so that they can be used in the cylinder head. So we machine the valves. It goes along with the machining process of machining the cylinder head for the valve seating process. Over here we have a surface grinder. This is for machining the cylinder heads and putting a new machine surface on them. In fact, right behind you, Catherine, right here, we have a cylinder head that was just recently machined. Okay, and it's got a nice, fresh, clean surface on it, and the students are now starting to put the valves back into the cylinder head. Over here on the in the corner, again, there's a cylinder head set up for machining. It's actually ready to be machined. It's not done yet, but we can machine the cylinder heads. We can also do some block machining in here where they actually recondition the surface of the block if necessary. So this is a head that's set up and ready to be machined, and the students will probably do it in the next class period. Over here we have, these are the Quickway head shop units. These are for reconditioning the valve guides and reconditioning valve seats prior to grinding the valves, and this is where they also machine the head for putting a new valve seat in.
So they're really becoming master mechanics here.
We'd like to think so, yes. Okay. Outside we have a couple of cleaning machines for cleaning all these parts. A lot of times these parts come in, they're not very clean. They're all dirty and greasy from years and many miles of use. So we have a jet cleaner outside that's designed for cleaning up the parts, and then they bring them in here and then they clean them up. We also have a bead blaster that is used to clean up the parts and make them really, really clean.
Excellent. And where should we go next?
Well, the transmission lab is next door. Okay, so we'll make our way into the transmission lab. This is our transmission lab. In fact, right over here to your left, Catherine, we got a brand new transmission dynamometer. And what we can do with that is that once the students have taken a transmission apart, reassembled it, tested it, and put it all back together, we can now put it on this dynamometer and simulate running it in a car. So we can do all the testing and diagnostics to make sure it's going to work before it goes back into the vehicle. It is brand new. Okay, we just got it. It does both manual and automatic transmissions, so we can check them against operating parameters to make sure they work okay. You can get the program done in 2 years.
In 2 years, okay. Yeah. And that's full-time?
That would be a full-time student. Okay. Taking their general education classes and taking the automotive classes and the other classes that they have to take to get either a certificate of completion or to get through an AS degree.
And your students still find employment because cars are in the United States and cars break down and people can get jobs.
We certainly hope so. Right now with the current economy and what's happening with the American manufacturers, maybe a little tough, but I think we'll work on getting students jobs.
Excellent, excellent. Okay, well, Stephen, thank you so much for taking us through today.
You're most welcome.
So here we are in a classroom for machine tool technology with Mike Absher and his fast class, express class that is learning the technology. Mike, tell us a little bit about what goes on in the classroom part of your program.
Okay, well, this class during the day is offered in express format, which means that you can actually complete 2 semesters in 1 semester. Okay. So that allows our students to get out of Chabot College and into the workplace in a faster format than what you do in the evening class, which is traditional 17.5-week semesters. And so this is actually the beginning of the second class of a series of beginning machine shop classes. And in here they make parts which are representative of what they would make when they go out and get a job. In fact, several of my students already have jobs and are just here to increase their skill levels so that it becomes a career instead of just a job.
Excellent, excellent. And so you guys are really on the fast track, huh?
Yes, ma'am.
Good, good. And so they're actually working, this is then a laboratory environment as well?
It's, it's 2 hours. Traditionally, it's 2 hours a week in lecture and 6 hours a week in lab. This is double that.
I see, I see. And so some of you are already working in the field and some of you plan to be working within a few months, is that correct?
I plan on doing this till 2010. Hopefully I want to stay here as long as I can, get as much as I can, and get all the knowledge before I get out there. Yeah.
And who of you in here is working now in the field? So tell us a little bit about what you're doing and how this helps you.
Oh, well, instead of just working on cleaning tools and stuff, now I get to machine at work, and you know, I get a lot of practice here and at work, so I'm sharpening my skills real nicely.
And your employer's happy, right?
Yeah, they pay for this now.
Very good. Okay, and there was another hand.
Yeah. I work at an engine shop and I'm the grunt, but with this class, you know, I get more experience, and then hopefully, you know, after I complete all the programs and all the certificates, and I can start my own business, and I'll have the experience from working at the shop I'm working at right now.
Very good. Thank you. Mike, do you want to give us a tour on some of the other locations where you teach people?
Sure, because this is a lecture room. Part of the class is lecture and part of it is lab. And so as you see here, there's a few of the parts that this project right here, which you might recognize as a trailer hitch ball, is one of the projects that they're actually in the process of drawing, engineering, and then they're going to build it. And so not only do you make tools that are of value in the fact of learning, but they're also things that you can make instead of going out and buying. So if somebody's diligent in doing the work in the classroom, they can actually walk away from here with somewhere between $200 and $400 worth of tools, precision measuring tools.
All right, so here we are in the shop, and I understand we're going to have a real live demonstration. Can you tell us about that?
Right. Well, first of all, this machine is one of the machines that was purchased with bond money from Measure B, and so it's a machine that does, it's a transitional machine that lets our people start out on manual machines and work their way up to computerized machines. So this machine does a little bit of the computerized work and some of the manual work. And so it's what we call a dual mode machine, because it can run both manually and computerized. So we have a beginning student who's going to run a part that has already been set up and is ready to make. So
Excellent. So let's take a look here. And why don't you show us what's going to be tuned there, Mike?
This is the controller that actually makes the machine move.
Okay.
But because of the fact that it's automated, it's potentially dangerous if the person doesn't know what buttons to push and when to push them. And so we have this machine running in what we call dual mode. So it's actually going to move when he turns this handle and this handle. So if he thinks that it's cutting too much or getting dangerous, then he can actually stop the cut by just turning the handle. So it will move in a curved shape and make a hammerhead, but it will stop if he stops the handle.
Okay, let's have a demonstration.
Okay, so hit the start button right there, and forward and go. Now push tracking. That'll allow it to be run by you turning the handle. Do it again. And move the black handle to start turning it. Other way. Okay, so we're going to go to run and then start. Go ahead and we'll start over. And are you sure that properly set? The answer is resume. Forward and go. Now turn the black handle. Okay. It says push tracking. And now forward and go again. You're going to do this 3 times. Then this is to make sure it's safe when you're operating it. Turn the black handle now. Just a little bit. Just notice it stopped again because it's safe. Start it up one more time. Turn the handle. And you can move this over out of the way and crank it up till it gets over next to it. And then you're going to change to this handle to slow it down. This is a slower handle. We know it's set, so go again. Change to the other handle, go the other direction. Can you step a little bit to your left, Philippe? That's not too noisy, is it? A little faster.
Guess it's when you go a shipwreck when you're going faster, huh?
Okay, turn it just a little faster. And now you can turn it as fast as you can turn it. It's going to move away. And you can see it roughed out the material. It took away the excess. Now it's going to come back inward. And so the faster he turns the handle, the faster the machine moves. So now it's making a curve. Okay, you can change to the other handle. Other way. There you go. One more time. Keep going. And that's it. The part is finished on that side. And we would do the same thing to cut the other side, and then the part would be complete.
Excellent. So this is all part of their training.
All part of their training. And they've just, today was the first introduction to even turning this machine on.
Oh my goodness.
But we've been spending a lot of time learning how to use the straight manual machines, which we have also purchased. We have older machines, and also new machines that were purchased with the bond money.
Can we take a look at that?
Right. This is one of the new machines that was purchased with the bond money. It's Hardinge. Many shops in the Bay Area have these. They're a very common machine, but most shops can't afford more than one. Because we're a school, we actually have purchased 6 of these, and that's quite unusual for that kind of machinery. So what he's doing, what Tom is doing, is he's cutting the other side of that part that we just machined in the automatic machine.
Oh, I see.
So he's doing this next operation to complete that project. So of course he has to measure. The students are encouraged to have their own measuring tools, but of course the school has all the tools that they need. So he's measuring his sizes, he's set up his tool bit, and he's getting ready to operate this machine and take a cut. To do the proper machining, you have to set the machine to the right speeds. If it's going too fast, it will have a tendency to ruin the tool bit. If it's going too slow, it'll have a tendency to make too rough of a cut.
Okay.
And so he's got his calculator there. He's doing the correct mathematics. So our program is very much in tune with the math and science division and the things that are needed to make this machine work.
And that's all part of their classroom.
It's all part of that classroom. There you go. Now you're ready. So as you can see, the part's not very round yet. When he gets done, the part will be round and match the other piece that was done on the automatic machine. So in the world that we live in today, machinists need to have both computerized skills and manual machining skills.
And tell us a little bit more about the breadth of the kind of jobs that people who have these skills can apply for.
Well, there's everything from entry-level jobs, which would be what you would get in a traditional one-year program, and a 2-year program would entail enough of the advanced classes where they could go ahead and start start to actually build a full career. And so in the full 2-year program that we have, which is in both certificate mode and also AS degrees, you can get either one or both. And so the classes are usable in both the certificates and the AS. You don't have to double up on them. That's a common question that we get. But our people will go out and go to work. Entry level wages are $12 an hour, and then they go up. I have several of my ex-students that have not only finished their program, but they finished it in the last 5 years, and they're easily in the $30 an hour range. And so they can make a truly living and comfortable wage for the Bay Area.
And all of that in 2 years?
In 2 years. Many of my students now, though, are coming back to get the new technologies that we've added because of the bond, which are not available in any kind of training mode anywhere in the Bay Area.
So additional training.
In additional, yeah. So we have people that come back who are already working in the field, and now they're coming back to hone their skills and add new things that are going to take them to the next level of, accomplishment.
And so how are we doing here?
He's doing real well, making lots of little chips.
Who's our machinist?
This is Tom Rawson.
Hi, Tom. Nice to meet you.
Hi, how are you? I'm making Parmesan for the pasta.
I see. What's the material you're working on?
Some kind of plastic.
It's probably a polypropylene.
Okay.
It's when we don't know for sure, we call it white plastic.
I see. Okay.
But we could be using, this could be a nylon, but the way it's cutting, it looks more like a polypropylene. He made his own tool bit. That tool bit that he's using there is one that he made earlier in the classes.
Really?
So that, we learn the precision of how to grind a tool to the proper angles so that it'll cut properly and make the chips flow off of the material and break off into little segments, which is much safer.
Like curly cues instead of...
You're right.
So these are very light cut. As you saw over there, the chips were much larger,
yes.
But it's the same material. It's just a matter that he's doing the finishing cuts, so you don't want to get in a hurry. And so he's going to continue that until he completes the final shape and length and all of the dimensions that are required for that project, and then he'll go and make the holes in the side for the handle to fit in.
I see.
So I can show you an example of what that would be if you want to walk over to another part of the shop.
Let's do that. Let's move ahead.
Thank you. Okay, so this is an example of the hammer that's being made by the students that we saw earlier.
Beautiful.
Except this one has an aluminum handle and a brass head. The one we were watching was one that the head will be made out of plastic. Sometimes when you're assembling a part or a bearing or something, you need to hammer and not damage the bearing, and so we use a plastic hammer to do that. And so this is just another one of the tools that they'll make, and they'll make the handle with a taper and also these knurls, this kind of a crossing pattern, and you can see your hand grips real well with that.
That's beautiful.
And so this is approximately what his will look like, except it'll have a plastic head. Now these machines that are here that we're standing around, this is more of our computerized machines. And with those, our students, so that they have a project to work towards, they make a full set of chess pieces.
Oh, for heaven's sake.
And so it isn't that it's so expensive or anything like that. It's not a tool that they're going to take out and use in industry, but it gives them all the skills on how to make intricate shapes on a machine that can do turning, which is lathe work, and milling, because this machine right here is a machine that will do both turning and milling. So this part right here started in here, right like this, and then it not only turned the shape, but then it took and put cutters in the machine to actually mill the flat sides, which is something that's very new, very high tech. In fact, if I could teach you how to run this machine at the end of the time that I taught you to run it, I could put you to work the next day.
Wow.
Because this particular type of machine is called a mill turn, and there's so few people that are out there trained to do it that industry is just clamoring for them.
That's fantastic. And those are beautiful.
Yeah, and then some of the gentlemen go out, or women too. We have, in my evening class, I have 4 women in my class right now, and they're doing very well. Sometimes they show up, the guys, because they're more used to working with intricate things in their hands than some of the men are. And so these machines were, of course, all purchased with the bond money, so we've upgraded our program considerably from what we had 10 years ago.
Well,
and even older.
We could encourage people to check out. Do you have open houses? Do you show people some of the
We do it normally in the spring, and that's just because we never can rely on the weather. We like to leave our roll-up doors open and let people just wander in and out as they have an open house in our whole division. And so, yeah, we do that. We're working on right now, my computer-aided manufacturing group is actually working on a project that we're going to make to give away at open house.
Excellent.
And so they're not working on it right now, but I'll let you see their computer work that they're working on right now on the other side of the shop. This is a fixture that Jose is making for the grinding machine. It's a Myford grinding machine, and it needs some modification, and so he's been designing and using SolidWorks, which is our design CAD program. He's taken this several semesters so that, as you can see, he can maneuver things around. He's trying to make it so all the parts fit together where they're supposed to be, and then when he's done, it'll model it, and we can print each piece, and then they'll manufacture that to actually build the fixture.
Amazing.
And
you
so,
enjoy it?
yeah, pretty good.
Excellent, excellent.
And he's been working in the field for quite a while.
You have? Yeah. Okay, and what do you do? Are you working in automotive technology, or where?
Machines.
Machine shop.
So basically what we do, as the professor was telling you, so we basically got and design some parts some of the time just to improve the lines of production, so to make it more effective and faster.
Excellent. And what was this program called?
SolidWorks. We teach SolidWorks. It's part of our MTT 50 class, which is our entry level, the very first class that they generally take. It's taught in the fall, it's taught during the daytime, and in the spring it's taught in spring. And so it's
people could come and see this in the spring. You're hoping
absolutely
to have this as part
right.
of it. Sounds very exciting and really a good job to have.
Yeah.
Right.
Thank you.
So this is one of our newest part machines that we have purchased. It's called a three-dimensional printer because it works in some ways like a printer that you might have on your computer at home, except it lays one layer of plastic down at a time, each layer being just a few thousandths thick, about the thickness, a little thicker than a hair.
So it's a
and
3D
then
printer?
Yes, it prints in 3 dimensions. So you can see here, this was a part that was designed poorly, by the way. You can see that the wall was too thin, and so it broke loose. But we have parts, they actually get made right on this plate, which sits inside this machine. And then you can proof out a part or test it to make sure that the concept is workable without making many parts, putting them together and saying, oh, they don't fit, let's try it again and change everything. This is what's called, the term in the industry is called rapid prototyping. And so here we have a little gear spline that actually was all made as one piece.
So
it
wasn't several pieces, it was just
it wasn't several little pieces. It wasn't a little gear, a little shaft, a little another gear. It was all made at one time from the bottom up. And when it's done, as you can see, once you dissolve the support material, it makes layers of support material so it's strong enough to support itself. Then you can see it actually rotates.
So it's a proof of concept.
Proof of concept, and so that's why it's called rapid prototyping. Here we have another part that was made with a slightly different plastic, but it still just fits in the machine, and this is a crescent wrench, and you can see as she rotates it, it's closing and opening, and that's one that was also made on this machine. This part right here was actually too large to fit in the machine. It was actually so large that it would not fit on the platen, that black plate that we start on, and so what we did is we made it, we drew it in SolidWorks, and then we shrunk it down to a size that would fit on the machine. You can actually print many parts at the same time. It's slow, but at the same time it's much faster than building each individual component and then trying to bolt them together and find out, oh, this was too small, too thin, too fat. And so it's a very useful tool. It's used by all the big corporations to test out everything from how you make a Microsoft mouse. You could draw this and actually print that piece and build it by using black plastic.
In prototype, so you
in
can
prototype.
actually see it.
So in here we have a wide variety of computers running many different types of software for what we call CAD. Right. In fact, when this whole building is renovated, as you noticed, it was quite busy in our shop. We're expanding to a larger space. It's in the same building, but we're going to actually reposition machines and put them in a way that there's more room for expansion and things in the future, because this whole environment is growing, and people, as I tell many people when they ask, well, what do you teach? I tell them I teach my students to become taxpayers, because almost every one of them goes right to work.
That's excellent. Mike, thank you so much for taking time
Thank
with
you.
us today.
Bye.
This is Catherine Pincus, and I'm here with Dan Rodica, and today we're talking about welding technology. Welcome, Dan.
Thank you very much for coming in.
And so, Dan, I wonder if you would tell us a little bit about the equipment that we just saw down this aisle.
We try to segregate our processes in pretty much two areas. This area is more stick welding and MIG process.
What's stick welding?
Stick welding is a process in which you use a rod, which now have fluxes on, and it's actually one of the most common type of welding.
Okay.
And MIG is actually a newer process in which now we use a wire feeder, continuous wire feeder, and it's actually employ different types of equipment for it.
And what we're seeing are booths here, right, where students actually practically do welding.
Yeah.
In these spaces,
Yeah,
and they're protected.
Yeah, in the normal condition, we have all these stations now in which now the students are performing their welds based on whatever schedule they have, whatever classes they are in.
And there are different kind of welding techniques that students can learn here at Chabot.
Yeah, we have 4 processes which actually we try to now make our students get prolific in. One of them is already mentioned, 2 of them. Stick welding or shielded metal arc welding. Shielded metal arc welding.
Shielded metal arc welding. Okay.
We have MIG, which is a kind of popular term for gas metal arc welding.
Okay.
We have a flux core process, and we have TIG or tungsten, gas tungsten arc welding.
And so students learn a variety or all of these depending upon their jobs?
Yeah, it depends on what classes they are involved with. They will now. We have introductory class in which we try to give a perspective, not what is all about, what is welding all about, and based on that they start getting into some area like MIG and TIG, or eventually flux core and arc welding.
And what's happening here is the students are learning the practical skill sets, and then do they get certified at some point? How do you know they're proficient?
Welding program is very manually intense process. We have a lot of students, have different types of students. Some of them are come to perform welds as an improvement to their whatever qualifications they already have, or eventually they start from knowing nothing about welding, and they get quality to the point where they can get a job.
And I think you have something artistic to show us over here. So Dan, we were talking about the fact that people use welding for a variety of purposes. To my right, I see an amazing structure. What is this?
This is part of the welding for artists. It's a course which actually is geared towards people which want to use our labs, just to emphasize the artistic potential.
So this is a sculptured piece.
Yeah.
Produced by one of our students.
Yeah, which is not present right now.
And does it demonstrate a variety of techniques?
Obviously, we can demonstrate the fact they know how to use the shop equipment to start with, they know how to do measurement, proportional, whatever, design, and eventually welding itself. So a lot of requirements to be able to make something like this.
It's very beautiful.
Yeah,
and then there's some equipment here. Would you like to show us some
Sure,
of the equipment?
sure. Right behind us we have what you call a plasma cam. This was a donation, about $10,000 donation. And what this piece of equipment can do is, if you come this way, I'll show you, we have a computer which you can actually design or eventually scan certain drawings, and the machine automatically will be able now to cut the design itself. So it's pretty much top of the line.
So these are very intricate metal designs that I see here?
Yeah, these are a collection of different artistic designs, something which the student can actually see, approach, and eventually now perform.
And the student produces it on this piece of equipment here?
This piece of equipment, other support equipment you have in the shop, welding equipment, so it's not only this machine.
So they can learn some very fine skills here.
Yeah, I will say so. Yeah, they are.
And let's look at some of the other pieces of
Sure.
equipment. So Mike, this looks exotic. What is this?
This is one of the support equipment which we use in our welding shop. Welding is not only welding, you have to prepare your plates, you have to cut material. So what we have right here is a beveling table, a cutting table. The student will be able now to cut certain angles with this machine, and after that perform some welds to ensure full penetration.
And what is this? Is this an example?
This is not on the, yeah, this is actually a sample. One of my students in the morning did some welds in the morning.
So that's an example.
Yeah. Right there you have other piece of equipment that are shear. Next to it we have a,
So this is,
it's a table.
and what's handled on this table?
This will be a support for some long sheets of metal which will go inside of the machine.
Okay, okay. This?
But there we have a lathe, and right behind we have a mill machine, a Bridgeport mill machine. These are support type of equipment which actually we use for pipe welding or whatever.
So these hold the pipes in place while they're welded?
Yeah, I'm not sure if I have one in here. Yeah, that one. So we prepare the pipe, we bevel it, we put two together, and eventually, somebody have to do some welds on it.
Beautiful. Okay, so all of that work is done here.
Yeah, it have to be done here.
Okay. And this piece of equipment does what part?
This is a lathe. This will turn, go right inside and will turn actually the bevel. That's for surfacing. It's again a support type of. This is a pipe bender. So you can bend pipe up to from a ½ inch up to 3.5 inches, or eventually tubing. Same sizes. And this is again it's a brand new piece of equipment which you use for art class.
Okay, so would you describe this equipment that's out here in the bay?
This again, it's support equipment. This is what you got in there. It's a bend saw, a vertical bend saw. You have a brake in here. You have a wet saw This is a pen brake, smaller size. Right behind we have it's a bench press and other equipment like you see.
So this is all to mold the actual metal so
Yeah.
that it can be welded.
Yeah.
So that pretty much students can design different products in different ways and then complete their welds.
Yeah, they can come in whatever project they have. We have all the equipment now to be able now to fulfill their requirements.
What a great resource.
Yeah, it's a great place. It's a great shop. We have brand new equipment, so everything due to the Major B was actually replaced to a certain degree. So we are running on all the pistons now, I guess.
State of the art and
Yeah,
here
it
at
is.
Chabot College.
It is.
Excellent. So students come from a variety of backgrounds.
Yeah, different genders, different ambitions. Some people want to certify in welding on different processes. Some of them just learn for themselves.
So people
Some
who
of them-
certify go into construction, go into other fields.
Yeah, I guess all the industrial area, in one form or another, it will need some kind of welding in that. So we are here to prepare students for any eventuality in which they have this kind of contact with our.
So they have full-time support from the instructors when they're here. Do they design their own projects, or do you put them through a series of specific projects?
We have a consolidated program, so we go through some of the students through a specific type of schedule, and we do that one because we realize it's easy for them to learn and train. They're trained in this way, and some of them, they actually kind of specifics. Like we have a 68 class, which is specific for certification. So they just perform welds, and the idea now they'll take a test. And actually, if they take a test with us, we assist them. So we take the test to the lab, and eventually they get certified with certification from the National Society.
And that helps them in their career.
Obviously.
Okay, good. Thank you, Dan, so much for taking us through today.
Thank you.